Alright, solving systems of equations review. First thing I'm going to talk about is substitution. When you are substituting, you need to get a variable by itself. So for number one, I already have y by itself. So I'm going to take what y is equal to, and I'm going to substitute y in the other equation. I'm taking y out, and I'm putting in its replacement, what it is equivalent to, 6x minus 5. Always put it in parentheses. I can't do anything, can't distribute anything, can't combine like terms or anything inside the parentheses, so I'm going to rewrite it. X plus 6x is 7x. I had to add 5 to get it to the other side. 7x equals 14. And when I divide by 2, when I divide by 7, x is 2. So I've got the first part. I'm going to plug into one of the equations. It doesn't matter which one. 2 plus y equals 9. Subtract 2 from both sides. And y is 7. So my answer is 2, 7. For number 2, again, solve using the substitution method. I have to get a variable by itself. I don't have one by itself, so I'm going to pick the variable that does not have a coefficient. Negative 3x plus y equals 7. To get y by itself, I'm going to add 3x to both sides. And that gives me y equals 3x plus 7. So I'm going to plug this 3x plus 7 into the other equation everywhere that I see y. This is why it's so important to use parentheses, because I'm going to have to distribute this 2 to everything in the parentheses. 5x plus 6x plus 14 equals 3. Combine like terms. At this point, I'm not doing any inverse operation. I'm just combining them. It's a positive 5 and a positive 6, so that's 11x plus 14 equals 3. Rewrite it over here so I have more room. Subtract 14 from both sides. 3 minus 14 is negative 11. Divide by 11. X equals negative 1. I'm going to take that negative 1 and plug it into one of the original equations. Negative 3x, which is negative 1, plus y equals 7. Negative 3 times negative 1 is 3. Bring everything else down. Subtract 3 from both sides. Y is 4, so my solution is negative 1, 4. X, comma, y. X, y, negative 1, 4. Alright, so that's substitution. You isolate a variable, you plug its expression into the other equation for that same variable, and then you solve for the only variable you have in that equation. Find that value, plug it into one of the original equations, find that value, and then that's your order of pairing. Alright, solve each system of equations using elimination. For elimination, you have to have opposites. I already have opposites. First and foremost, it has to be in standard form. Something x plus something y equals something. This is in standard form. So I'm going to add 5x plus negative 5x cancels itself out. That gives me 0. So I'll move on. 6y plus 2y is 8y. 13 plus 11 is 24. Divide by 8 on both sides. And y is 3. I'm going to take that 3 and plug it in for one of the original equations for y. That's 2 times 3 equals 11. 2 times 3 is 6. Subtract 6 from both sides. Negative 5x equals 5. Divide by negative 5. And x is negative 1. So that's my solution, negative 1, positive 3. Alright, for number 4, I don't have opposites, so I'm going to look and see, do I have something that would be really easy to turn to opposites? Negative 3 won't go into 7, and 7 won't go to negative 3, so I'm not going to use those. Negative 2 will go into 4, so I'm going to use the x's. The opposite of 4x is negative 4x, so I need to multiply the top equation by 2, every single number. 2 times negative 2x is negative 4x. 2 times negative 3y is negative 6y. 2 times 6 is 12. cancels itself out. I eliminate that variable. 7y minus 6y is y. Negative 18 plus 12 is negative 6. I'm going to take that negative 6 and plug it into one of the original equations. Negative 2x minus 3y equals 6. Negative 3 times negative 6 is positive 18. Subtract 18 from both sides. I get negative 2x equals negative 12. Divide by negative 2 because you're multiplying negative 2 times x. So to get rid of that negative 2, I have to divide. And my x is 6. That gives me 6, negative 6. And of course, when you find these solutions, you can always plug them back in to shape them. If you get a true statement, you know that you did it correctly. And a word problem. Set up a system of equations and solve using any method you choose. The price of a sweater is 5 less than twice the price of a shirt. If 4 shirts and 3 sweaters cost $2.75, find the price of each shirt and sweater. So I'm looking for shirts, X, and I'm looking for sweaters, Y. When you have word problems, you answer using words unless it specifies otherwise. So it doesn't matter which variable you use for which one, because you're going to answer this using words. You're going to say each shirt costs this much, each sweater costs this much. So as long as you know which one you've identified, that's fine. All right, the price of a sweater, and I've labeled the sweater as Y, so Y is, when it says is, that's equal to 5 less, that's going to be a negative 5, then twice the price of a shirt. A shirt is X. If 4 shirts and 3 sweaters, so that's 4X plus 3Y, equals 275, then find the price of each item. This problem is set up easiest to use substitution. So I'm going to take this negative 5 plus 2x, and I'm going to substitute y in the other equation. 4x plus 3y, which is negative 5 plus 2x, equals 275. First thing that I do is distribute. Bring down my 4x. 3 times negative 5 is negative 15. 3 times 2x is 6x. And bring down your 275. 4x plus 6x is 10x. Once you combine like terms, again, you're not doing the operation here because it's on the same side of the equal sign. So I'm just combining them, adding them together. I'm going to add 15 to both sides. That leaves me with 10x equals 290. Then I'm going to divide by 10 on both sides. And when I do, I'm going to get 29. Plug in 29 for x. Y equals negative 5 plus 2 times 29. 29 times 2 is 58. Negative 5 plus 58 is going to give me 53. So I'm going to say the shirts are $29 each, and each sweater is $53. And this concludes the review for systems of equations.